Before you begin encrypting objects in S3 using server-side encryption with key management service, you need to understand some of the key concepts in KMS. Following key definitions are extracted directly from the documentation. So you have a customer managed key, or a CMK. This is a primary resource in the KMS, are customer master keys. Typically you use a customer master key to protect data encryption keys or data keys, which are then used to encrypt or decrypt larger amounts of data outside of the service. CMK never leaves AWS KMS unencrypted, but the data keys can. KMS doesn't store, manage, or track your data key. There is one AWS managed CMK for each service that is integrated with KMS. When you create an encrypted resource in these services, you choose to protect that resource under the AWS managed CMK for that service. This CMK is unique to your AWS account and the AWS region in which it is used. It protects the data keys used by AWS services to protect your data. A data key is used to encrypt large data objects within an application outside of KMS. In the context of the S3 server-side encryption, the application will be S3 itself. Key rotation and backing keys. When you create a customer managed master key in KMS, the service creates the key ID for the CMK and the key material. This is referred to as a backing key. It is tied to the key ID of the CMK. If you choose to enable key rotation for a given CMK, AWS will create a new version of the backing key for each rotation. It's the backing key that is used to perform the cryptographic operations such as encryption and decryption. Automated key rotation currently retains all prior backing keys so that decryption and encryption can take place transparently. CMK is a simple and logical resource that does not change regardless of whether and how many times the underlying backing key has been rotated. Right. So in this step we're going to create a CMK using the console. It's accomplished from the service management key, the key management service. The CMK that you create here will be used in S3 server-side encryption using KMS process. So we need to go to KMS. Create a key. Right, CloudMech will clean up the lab environment for you once the lab is completely terminated. Okay. Click on the create a key and expand the options to see the following values. We need to make a symmetric key. It's going to be used to encrypt and decrypt. We're also going to enable key material origin as the default. AWS will generate the key material for encryption, and regionality, it's going to be single region. So we can next. Right, the alias we need to give it is this. Append a unique number to the key alias as it needs to be unique, so we need to just customer master key, so the description needs to be this as well. We can click on next. We don't need to add a tag. Now we're going to define the key administrative permissions. This allows users and roles to administer the CMK but not perform cryptographic operations. In a production environment, this is sometimes used to easily grant limited access to other users. The allow key administrators to delete the key checkbox makes this explicit if deleting keys is allowed. Alright, so we don't need to do that. We're going to allow admin to delete. Users or usage permissions, we're going to leave that default. And key policy, do we need to change that? No? Okay, so we just finished that. Right, CMK is created. Confirm the key created correctly and the status is enabled. Which it is. So we've manually created a customer managed key in the console. The key can be used to encrypt, decrypt. However, in production, different policies typically need to be configured. So there we go. We've got symmetric, key rotation. Yeah, that's it. So we can now use the arm, pull the key, and then use it. I think that's the end of the lab. Oh no, there we go. So we can now actually use it. So now we go to S3. There should be a bucket in here already, so we'll click on that. Alright, what we're going to upload. Add a file. There's a small, so we need to install. So we've got a logo. So we're going to add that logo. Add files and select a small file. Download this file and select it. Expand the properties. Server-side encryption, there we go. So this is currently done through a managed key. We're going to override the settings. We're going to server-side encryption with a management key. I'm going to choose a key. The one that I made. There it is. And then save that. We can now verify that the object is encrypted using KMS by checking that the encryption field is done. So where is it showing us that? I can see it's encrypted there with the key. It's just
Fix it says, "Hi."
Hello. I love this. So this lab says you can verify the object is encrypted using SSE-KMS by checking that the encryption field is AWS KMS. So that's literally just this bit, and there's no image. And the image they've put is actually this. They've screenshotted that, which doesn't tell you that. So yeah, done. Right, so in this lab step we have encrypted an object in S3 using the KMS key. We also configured KMS as the default encryption property for all uploaded objects. However, this will not enforce that all objects use KMS because it can be overridden with every request. So, I guess... Oh, there's a check here, so we can actually verify that that file is encrypted correctly. So, so yeah, it did work. And that's definitely the end of the lab. No, okay. So now we can... Now we're going to enforce S3 encryption using a bucket policy. So it's useful to know that the individual objects can be encrypted, but we can also enforce that all objects are encrypted. We're going to implement a bucket policy that requires KMS to be used for all objects put into the bucket, as well as specifying the CMK used for the encryption. Policy should be enforced when the bucket is created, since existing objects in the bucket will not be encrypted when the policy is applied. So if we go back to the bucket, and we go permissions, we've got a bucket policy there, so we're going to copy in this policy. Please paste. Why aren't you pasting? Oh, public access is blocked because block public access settings are turned on. Let's try and edit it. Okay, that's better. Right, so this is going to require server-side encryption using KMS, and then we're going to deny the upload if it isn't SSE-KMS encrypted. The effect is a deny. Principal is all objects. Occurs whenever you do a put object action. We need the bucket name. Let's paste that in. And then every single thing in the bucket. Condition we're checking is that the string doesn't equal AWS KMS, the server-side encryption. So this metadata must have that, otherwise it gets rejected. Right, replace your bucket name. Yeah, okay, we've done that already. Save the policy. Now it will be enforced. And now if we click on the Objects tab, we need to add another small file. Save this image. It's going to upload the AWS logo. If we click upload, we'll observe the image doesn't appear because in the bucket contents. So the upload failed. Clicking upload without configuring any properties about encryption will cause it to fail. Retry the upload, and this time set the property for the encryption to use the master key using your CMK. So re-upload. Drag the file in again. So we're uploading the AWS. We're going to do Properties, server-side encryption, specify a key, override the bucket, use KMS, or SSE-KMS, and we're using, choose from the keys, the lab key, and upload, and then that works. Sweet. Right, so now in this lab step we configure the S3 bucket policy to require SSE-KMS encryption for any new objects uploaded to the bucket. Clients are required to explicitly configure KMS properties on the object. If you prefer to automatically set KMS properties, you can set the bucket default encryption accordingly. If the client tries to override the encryption to use a different encryption method, the upload will fail. If you have time remaining, you've already passed the validation check. Try to modify the policy so only a specific CMK can be used. So we go missions. So if we want to change this so that it has to have a specific CMK, then we'll change this to be deny upload if not. Specific CMK, and we'll deny everything on the put object action within the bucket. This time we check for the string not equals, and then we've got another metadata. So this time we look at server-side encryption AWS key ID, and the key ID will have to be the ARN of the key, so we need to go KMS. Let's copy the ARN. So we want the ARN to be that. Save it. And then now we're blocking anything that doesn't use that specific key. Right, let's see if that works. Cool, that was it.